This video is on analyzing and comparing statistical data, and it's lesson 22 in your book on pages 127 through 133. Now, analyzing and comparing statistical data can be really important to you as a consumer because people are always trying to sell you stuff, and unless you know how to read and compare your statistical data and look for things like biases and if it's displayed correctly, you'll be fooled every time. So we're going to talk about some different ways that numerical data can be displayed. And the first way is through bar graphs. Bar graphs use vertical or horizontal bars to represent data. Now here we have a bar graph. It says a sample survey asks students to name their favorite type of pet. The results are shown in the bar graph. So the title of the graph is Favorite Pets. On the y-axis here we have types of pets, and then on the x-axis we have numbers of students. Now, bar graphs are most often used when you have qualitative data. So you have a number of something, but you're using things that aren't numerical. Fish, hamster, bird, cat, dog, those are not, you can't represent those numerically. So that's why we used a bar graph for this. Now, the first thing we need to do is use the bar graph to complete the table. This is an example. It does need to be in your notebook. So they give us each pet, and they want us to complete the number of students whose favorite pet is each one of these pets. So we'll start with dog because it's the first in our table. So if we look at dog on our bar graph, the bar goes to about right here. Now it's close to 150, but not exactly, and it's between 150 and 200. So I'm going to estimate about how many people have this favorite type of pet. So let's see, it's not quite halfway, so it's not 175. I would estimate it to be at about 160. So about 160 students said that that was their favorite type of pet. Now let's look at cats. The cat bar goes not quite to 150. Halfway here would be 125. I would say this is probably 140. Now let's check out birds. The bird category doesn't go all the way to 50. About halfway between 0 and 50 would be 25. So this looks to be about 40. It's closer to the 50 than to the 25. Hamsters. Hamsters are between 50 and 100. About halfway right here would be 75, so that might be about 70. Again, we're just estimating. And for fish, we're between 50 and 100. Halfway, about right here, would be 75. So I'd say that was maybe 85 or 90. Alright, now the questions are asking us, first of all, what information is shown on the vertical axis? Well, here's our vertical axis. The vertical axis is types of pets. The horizontal axis, right here, tells us the number of students. Now they want to know how many students were surveyed. Now it doesn't tell us in the information about the graph how many students were surveyed. So we're going to need to use this number of students category that we have right here. Now, they will only ask about their favorite type of pet, which means each person would have only one response. So if we find the sum of all the people that have each favorite pet, then we can find how many students were surveyed. Now I said there are about 160 people who like dogs, and 140 people who liked cats, about 40 who liked birds, about 70 who liked hamsters, and about 90 that liked fish. So if we add all those numbers together, we get 500. So it appears that there were about 500 people that were surveyed. Now the next question says, which pet did students choose twice as often as the hamster? Well, the hamster, there were 70 people that chose the hamster. Now, twice 70 people would be 140. So which animal was chosen by 140 people? The cat. So the cat was chosen twice as often as the hamster. Now this is another example. It needs to be in your book. Double bar graphs show two kinds of bars side by side, so that allows easier comparison of two related sets of data. We use double bar graphs when we want to compare the amounts of two things. So Sal and Harry both own sandwich shops. The double bar graph shows the number of shops they owned at the end of each year. What conclusions can be made from the graph? Well, the only conclusions that we can make from a graph come from what is inside this graph itself. So we can say, let's see, the light blue bar is Sal's deli, the dark blue bar is Harry's deli. See how all the light blue bars are equal to or smaller than the dark blue bars. So a valid conclusion would be that there were fewer of Sal's delis than there were of Harry's delis. Most years. Of course, that 1 year they were equal. In 2004, they were equal. Now, another conclusion that you could make was that Harry's deli increased the number of shops that they owned each year, whereas Sal's deli increased until 2004 and then decreased in 2005 and 2006. Some conclusions that you cannot make from this graph have to do with what kind of business each deli was getting, how many employees they had. You can't make those conclusions based on these graphs because there are lots of other factors that affect how many sandwich shops they open. This next example, again, needs to be in your notebook. Next type we're going to talk about is stem and leaf plots. This is a data display that uses some digits, always the first digits, as stems, and then the rest of the digits as leaves. The stems have a greater place value than the leaves, and they're useful for organizing and ordering data. So they're the best for putting data in order. This particular stem and leaf plot shows the ages of members of a hiking club. Find the age of members of the hiking club that occurs most often. Okay, now here's how we read this. The stem is the first digit, and each of the leaves is the last digit, or the last few digits. Now, if we have the stem of 1 and a leaf of 10, that tells us, of 0, that tells us that this is 10. A stem of 1 and a leaf of 7 gives us the value of 17. So it looks like we have 10, and then 1, 0, another 10, and then 1, 7, so a 17. 2, 4 is a 24. 2 and 6 would be a 26, etc. for the rest of the chart. Now we want to find the age of the members of the hiking club that occurs most often. So we're looking for one of these numbers that occurs the most. Now see, I have 1, 0, and 1, 0, so I have 2 10s, so that's quite a few. I have a 5, 6, and a 5, 6, so I have 2 56s. But look here, I've got 3 1s in this category right here. Now that does not mean that 1 occurs most often, but that 4, 1 occurs most often. So 41 is the age that happens most often in this group of hikers. This next example is about line graphs. Line graphs are lines drawn through points on a grid, and the best thing for line graphs to display is change over time. So whenever you are looking to display a change in data over time, you use a line graph. Now, just like with bar graphs, you can graph two related sets of data using a line graph. The difference is, with bar graphs, you're not graphing how they change over time, but simply specific amounts, whereas double line graphs are best used to display change over time. This is an example that needs to be in your notebook. The double line graph shows the same data as the double bar graph in example 1. So they show us the number of sandwich shops that each of these chains had, so Sal's Deli and Harry's Deli. What conclusions can you make from each graph? Well, we can make a conclusion that the number of Harry's Delis increased every year. So how it changed over time. So number of Harry's Deli steadily increased from 2001 to 2006. We could also say that Sal's increased until 2004 and then decreased until 2006. Those are some conclusions that we can make from this graph. And here's another example. We're going to compare data using double bar graphs. So we have a table here and it shows Andre's bank account transactions. We want to make a graph to compare the deposits and withdrawals. Now the reason that we're using double bar graphs here is because we have two different sets of data and we want to compare them. Not compare how two different sets of data change over time, but simply compare their amounts. So we're going to make a graph to compare these deposits and withdrawals. Alright, so we know that for each deposits and withdrawals, we're going to have the same months. So I'm going to make the months part of my x-axis. So I'm going to draw my graph. I'm going to have January, February, March, April, May, and June. Alright, now I need a different bar for deposits than I have for withdrawals. So I'm going to color in deposits and I'm going to make withdrawals clear. Now I need a scale for each of these. So see how the numbers vary from 100 to, let's see, what's the biggest one? About 475, oh no, 500. Okay, so I'm going to make each of these marks 100. So this is going to be 100, 200, 300, 400, and 500. Alright, now I'm going to start with deposits. In January, he deposited $475. So I need a bar that represents $475. Now halfway between 400 and 500 would be 450. So I'm going to make this my 475 bar. And since it's a deposit, I'm going to color it in. I know this is an ugly graph, please forgive me. Alright, now in February, he deposited $200. So $200 would be about right there. Make my bar, and since it's a deposit, I'll color it in. In March, $350, so halfway between 300 and 400. Color that one in because it's a deposit. April, $425, so quarter of the way between 400 and 500. Color that in too. In May, $500, so all the way up to the top of the graph. And in June, $150, so halfway between 100 and 200, about right there. Alright, now let's look at withdrawals. In January, $100 was his withdrawal, so right there, even at 100, and I don't have to color that one in. $275 in February, so about right there. $350 in March, so halfway between, same place as the other one. In April, $400, so a little below this. In May, $200, so way down here. And in June, $225, so let's see, a little bit above 200. Alright, and there we have a double bar graph that compares deposits and withdrawals.